Okay, in this part, I want to tell you two approaches for radicals, and also when we have similar equations, we should do what. This is AIME 1 2022 last problem. We will solve this one, and also before that, we will solve a sample problem to learn what should we do when we have radicals. For example, here cube root, here square root, and when we have similar equations. And at the end, I will leave this part as homework for you to get good at the idea. Okay, if you wanted to solve more homeworks, here look, we have similar equations, and you should do the same thing. And the thing I will tell you, I released a solution of AIME 2 2023 full solutions. You can use that video. Also for this problem, replacement useful. Okay, so if you want to solve more problems with these ideas, replacement, similar equations, and two approaches for radical, as I said before, feel free to send message or my WhatsApp number in the description comments. So we first solve this problem, then we will solve this AIME problem, and at the end this problem as homework. So let's solve this problem. And during solving these problems, I will tell you, before solving this problem, I will tell you the idea for similar equations is what, and two approaches for radicals are what. When we have radical, for example, nth root in a problem, one way is to use changing variable, the first approach. Changing variable, and for example, in the following problem, we will use that changing variable. And second idea is to raise to the power of n. In AIME problem, we will use that here. If we have square root, we raise to the power of 2 to get rid of those square roots, sometimes more than once. These two things. And when we have similar equations, for similar equations, subtraction is so much useful. Similar equations, so you should subtract. It can be so much useful. Now for this problem, this says x is real number and x cubed plus 1 equal to 2 times cube root of 2x minus 1. I consider this part as a, so it will be what? X cubed plus 1 equal to 2a. A is what? A is cube root of 2x minus 1. I'm using first approach here. Now, I do this to get rid of radical. Now here, if you raise to the power of 3, a 3 is 2x minus 1. So if I take negative 1 to left side, a cubed plus 1 equal to 2x. So I write here a cubed plus 1 equal to 2x. As you can see, these two equations are similar. Here, if you change x and a, it will be this. The idea is what, when we have similar equations, we should subtract. So if we subtract, let's say it will be what? X cubed minus a cubed will be 2a minus 2x. Now we take 2a minus 2x to the left side, it will be x cubed minus a cubed plus 2x minus 2a equal to 0. Now here we factor from x minus a, it will be x squared plus ax plus a squared plus 2 times x minus a equal to 0. Now, for solving this part, I factor from x minus a, it will be x squared plus ax plus a squared plus 2 equal to 0. The product of two terms equal to 0, so the first term is 0 or second term is 0. So it is 0 or it is 0. First case, x minus a 0. Second case, x squared plus ax plus a squared plus 2 equal to 0. Now try to, at first we check case 2. Case 2 is impossible. You can consider it as, for example, let me tell you some approaches. You can consider is a quadratic equation in terms of x. So if you consider quadratic equation in terms of x, d will be what? Will be a squared minus b squared minus 4ac, 4a squared plus 2, which will be negative 3a squared minus 4 times 2, 8. It will be less than 0, so it's a contradiction. We don't have any real solution. X is real, and because a is cube root of 2x minus 1, a is also real. So it's not possible. Or you can consider it is a quadratic equation in terms of a. So d will be what? B squared x squared minus 4 times x squared plus 2. Similarly, it will be negative 3x squared minus what? If we calculate, it will be negative 3x squared minus. Okay, negative 3x squared minus 8. Again, it's less than 0. Let me tell you another approach here. I can say solution 1 for this part, solution 2. Solution 3. I can use identities. I can say x squared plus ax is x squared plus a over 2 squared. So it will be x squared plus ax plus a squared over 4. It will be plus 3a squared over 4 plus 2. And it is positive. Why? Because it is real number. At least 0 plus 2. It's at least 2. So it cannot be 0. So we proved that second term cannot be 0. Only first term can be 0. So x minus a equal to 0. X equal to a. And if we replace it here, let's copy this part. If we replace a with x, let's see what happens. It will be x equal to cube root of 2x minus 1. If we raise to the power of 3, x cube equal to 2x minus 1. So x cube minus 2x plus 1 equal to 0. And when we see these, for example, a polynomial with degree 3, one way is to find at least one answer, and then you can factorize. X1 is one answer, so x can be 1. And if we check, we will see it satisfies here. Because 1 plus 1, 2, 2 times 1 will be 2. And we can factorize. X1 factor is x minus 1. We place x squared to create x cubed. It will be x cubed minus x squared. Then I don't have x squared here. I can place x. So it will be plus x squared minus x. We can cancel if we have minus x. So I place minus 1. It will be minus x plus 1. So it is 0. Now, the first one is 0. We've checked x1 or second term 0. So x squared plus x minus 1, 0. Now, I use quadratic equation. If we have ax squared plus bx plus c equal to 0, then x is what? Negative b plus minus square root of b squared minus 4ac all over 2a. So here x will be what? Will be negative 1 plus minus square root of 1 plus 4, which is 5 over 2. So x equal to negative 1 plus minus root 5 over 2. So we found three answers for x: minus 1 plus minus root 5 over 2 and x equal to 1. So we've solved this sample problem, and I've explained for you for some first approach of changing variable and raising to the power of n. I've used this here, raising to the power of 3. So we've worked on both approaches and also similar equations. Similar equations here that we've subtracted. Now let's work on this AIME problem and this AIME problem as homeworks. Let's try this AIME. So for this problem, it says problem 15, AIME 1 2022. Let x, y, and z be positive real number. So positive real numbers satisfying the system of equations: square root of 2x minus xy plus square root of 2y minus xy equal to 1, square root of 2y minus yz plus square root of 2z minus yz equal to square root of 2, square root of 2z minus zx plus square root of 2x minus zx equal to root 3. Then what is 1 minus x, 1 minus y, 1 minus z whole squared can be written as m over n, where m and n are relatively prime positive integers. Find m plus n. So here, we will see we want 1 minus x. Always pay attention that what is the thing that we want to calculate. The sentence of the problem is what? Here it is 1 minus x, 1 minus y, 1 minus z. So we don't need to find x, y, z separately necessarily. We want to find this expression. And as you can see, for example, here, if we factor from x, we have 2 minus y. Here, y 2 minus. Here again, if we factor from y, 2 minus x. So we will see this similar to 1 minus x. If we consider 1 minus x as x prime, 1 minus y as y prime, 1 minus z as z prime, then let's rewrite these equations. The first equation will be what? If we factor from x, it will be x times 2 minus y plus Next one is y times 2 minus x. Okay, y2 minus x equal to 1. Second identity, or we can say second equation will be what? If we factor from y2 minus z plus square root of z times 2 minus y equal to square root of 2. And now here, square root of z times 2 minus x plus square root of x times 2 minus z equal to square root of 3. Now, I say, okay, x is what by x prime? 1 minus x is x prime. So 1 minus x prime is x. So if I want to rewrite first equation, the first one is 1 minus x prime. And we want to find what? We want to find x prime, y prime, z prime whole squared. Or we can say x prime squared, y prime squared, z prime squared. Let's work a bit on sentence. For hard problems, you should work a bit on sentence, a bit on assumptions. 2 minus y is what? 1 minus y is y prime. So 1 minus, let's see. If you add 1, 2 minus y will be what? 1 plus y prime. So we can write 1 plus y prime. So similarly, we can say y is what? X was 1 minus x prime. So y is 1 minus y prime. And 2 minus y was 1 plus y prime. 2 minus x is 1 plus x prime. Equal to 1. For second one, square root of y is what? Is 1 minus y prime. 2 minus z is what? 1 plus z prime. Plus square root of z is what? Is 1 minus z prime. 2 minus y is what? 1 plus y prime. Okay, it is 1 minus z prime. Here it will be 1 plus y prime equal to square root of 2. Third equation will be what? 1 minus z prime, 1 plus x prime, plus square root of x is what? 1 minus x prime, and 2 minus z is what? 1 plus z prime equal to root 3. Now I want to get rid of square roots, so I raise to the power of 2. So let's work on first equation first. Let me write this one first one, this one second one, this one third one. So if you count the first one and raise it to the power of 2, it will be 1 minus x prime times 1 plus y prime plus 1 minus y prime times 1 plus x prime plus 2 times square root of product. Let me tell you something. We know that a minus b times a plus b equal to a squared minus b squared, a simple and famous identity. So when you multiply this by this, 1 minus x prime times 1 plus x prime will be 1 minus x prime squared, 1 plus y prime, 1 minus y prime, 1 minus y prime squared, equal to 1. Okay? Now, let's simplify more. If we multiply, it will be 1 plus y prime minus x prime y prime plus 1 plus x prime minus y prime minus x prime y prime plus 2 times square root of 1 minus x prime squared, 1 minus y prime squared equal to 1. Now x prime negative x prime will be cancelled, y prime negative y prime will be cancelled. So here we can calculate 2 times square root of 1 minus x prime squared, 1 minus y prime squared. I want to get rid of this square root, so I take all things to right side. This one will be cancelled, so it will be negative 2x prime if you take it to right side, 2x prime y prime, minus 1 plus 1 will change to minus 1. Now we raise again to the power of 2 to get rid of square root. Second approach when we see radicals. It will be 4 times 1 minus x prime squared times 1 minus y prime squared equal to this squared. So 2x prime y prime minus 1 squared, which will be 4x prime y prime, 4x prime squared y prime squared plus 1 minus 4x prime y prime. Then here, if we simplify, it will be 4 minus 4y prime squared minus 4x prime squared plus 4x prime squared y prime squared equal to 4x prime squared y prime squared plus 1 minus 4x prime y prime. And then we cancel 4x prime squared y prime squared with this term, and we take all things to left side. So 4x prime y prime minus, or we can take it to right side or left. Okay, it's okay. We take it to left side. 4x prime y prime plus, I prefer to move it to right side. So it will be 4x prime squared plus 4y prime squared minus 4x prime y prime minus 3 equal to 0. So is the first simplified equation. We've reached 1 to 3. Let's call it fourth equation. Now let's work on second part. Okay, let's raise it to the power of 2. Again, 1 minus y prime, 1 plus z prime, plus 1 minus z prime, 1 plus y prime, plus 2 times the product. 1 minus y prime times 1 plus y prime will be 1 minus y prime squared. 1 plus z prime times 1 minus z prime will be 1 minus z prime squared, equal to square root of 2 squared, which will be 2. And then if we multiply, it will be 1 minus y prime plus z prime minus y prime z prime plus 1 plus y prime minus z prime minus y prime z prime plus 2 times square root of 1 minus y prime squared times 1 minus z prime squared equal to 2. So let's simplify as much as we can. Here, y prime, negative y prime, z prime, negative z prime. 1 plus 1, 2. With 2, you can cancel. Now, I want to get rid of this square root, so I take all things except these to right-hand side. So we can say 2 times square root of 1 minus y prime squared times 1 minus z prime squared. It is equal to 1 minus y prime z minus y prime z, negative 2y prime z. If you take it to right side, it will be 2y prime z prime. Now we simplify, we divide both sides by 2. We raise to the power of 2. Second approach when we see radicals, here square root. So 1 minus y prime squared times 1 minus z prime squared equal to y prime squared z prime squared. If we multiply, here we will have y prime z prime squared. It will be cancelled. So we have 1 minus y prime squared minus z prime squared equal to 0. And we can also write it as y prime. We can multiply by negative 1 y prime squared plus z prime squared minus 1 equal to 0. We call it, here it was fourth one, fifth one. Now let's simplify. Last equation here, third equation. Okay, in this part, again, we raise both sides to the power of 2. It will be 1 minus z prime times 1 plus x prime plus this to the power of 2, 1 minus x prime times 1 plus z prime plus 2 times square root of 1 minus z prime times 1 plus z prime is 1 minus z prime squared. 1 plus x prime, 1 minus x prime will be 1 minus x prime squared. Equal to what? Equal to 3. So, here let's multiply. It will be 1 plus x prime minus z prime minus x prime z prime plus 1 minus x prime plus z prime minus x prime z prime plus 2 times square root of 1 minus z prime squared 1 minus x prime squared equal to 3. Let's see, in next step we can cancel which terms? Negative x prime, negative z prime, z prime. 1 minus 3 minus 2 is 1. Now, we take negative x prime z prime, negative x prime z prime to right side. I want to get rid of this square root, so I take all things except this to right side. So we can conclude 2 times 1 minus z prime squared 1 minus x prime squared equal to 2x prime z prime plus 1. Now let's raise both sides to the power of 2. It will be 4 times 1 minus z prime squared 1 minus x prime squared equal to this part squared 2x prime z prime plus 1 squared. So we can simplify. It will be 4 minus 4x prime squared minus 4z prime squared plus 4x prime squared z prime squared equal to this part. First one squared 4x prime z prime squared plus 1 plus 4x prime z prime. We can cancel these two terms, and if we take to right side, it will be 4x prime squared, and the next one is what? 4x prime squared plus 4z prime squared plus 4x prime z prime. 1 minus 4 is minus 3 equal to 0. We call it sixth equation. Okay, these are our new equations. And as you can see, two of the equations are similar. This one and this one. Look, we have 4x prime squared, 4z prime squared here y prime squared. Here it is plus, it is minus, we have negative 3. So I've told you in previous problem when we have similar equations, we should do what? We should subtract. So if we subtract, 4x prime squared minus 4x prime squared will be cancelled. 4z prime squared minus 4y prime squared, 4x prime z prime plus 4x prime y prime equal to 0. Negative 3 minus minus 3, 0. Now here, I can divide both sides by 4, and now I want to simplify. It will be z prime minus y prime, z prime plus y prime, and plus x prime, z prime plus y prime equal to 0. And now I factor from z prime plus y prime, z prime plus y prime times x prime plus z prime minus y prime equals 0. So the first one is 0 or second one. Now let's check. Here, I want to check. I have here 1 minus x prime, 1 plus y prime. So, in this part, the problem says x, y, z are real numbers, positive real numbers. So x is positive real number, so 2 minus y should be also positive real number. So, or non-negative number. 2 minus y at least 0. So y is at most 2. Okay? And so here we can conclude y is at most 2, right? Because this part, so let's check the cases. Here we have two cases. Z prime plus y prime equal to 0, or case 2. X prime plus z prime minus y prime equal to we can say 0. So here z prime plus y prime equal to 0, we can also change it to z and y, or we can use it in our equations. So here in this case we conclude z prime equal to negative y prime, and because of fifth equation, let's copy this part. C control V. Okay, so if we replace here, we have y prime squared, z prime squared. We can say y prime squared minus 1 equal to 0. So 2y prime squared equal to 1. So y prime squared is 1 over 2. So in this case, we can say also z prime squared equal to this, because they are negative. One of them is 1 over root 2, one of them negative 1 over root 2. Now let's check other equations. For example, this one, equation 4, to see what happens. Okay, so In this case, 4x prime squared plus 4y prime squared. Y prime squared is 1/2, so 4 times 1/2 is 2 minus. Let's consider first, because the problem is it's symmetric with respect, so we should consider two cases. Case 1 is y prime equal to negative 1 over root 2, z prime equal to 1 over root 2. Case 2 is y prime equal to 1 over root 2, because look, y prime, z prime equal to negative y prime, z prime equal to negative 1 over root 2. Let's check these two cases. So if we check case 1, here it will be minus 4x prime times negative 1 over root 2 minus 3 equal to 0. Now, here it will be 4x prime squared plus 4x prime, or we can say 2 root 2x prime plus 2 minus 3 minus 1 equals. Now in this case, x prime will be what? Will be negative 2 root 2 plus minus square root of 8 plus 16 over 2a, 2 times 4, 8. So it will be what? It will be negative 2 root 2 will be negative root 2 plus minus 24 over 6 divided by 2, 4. And we know what? We know x, y, z are from 0 to 2. So x prime, y prime, z prime, because x prime is what? Is 1 minus x. 1 minus 0 is 1, less than 1, and at least negative 1. So if we consider this part, negative root 6 is around negative 2 point something. We can consider plus root 6 minus 2 or minus. If we have this negative, let's check it, negative root 2 minus root 6 over 4, it should be greater than equal negative 1. So negative 4 should be greater than equal this. So if we multiply by negative 1 root 2 plus root 6, so 16 will be greater than equal to 2 plus 6, 8 plus 2 root 12. And then 8 should be greater than equal to root 12. So 4 should be greater than equal to root 12. It will be okay. Okay, so let's check this case. X can be these numbers. So let's consider case 1. In case 1, y prime equal to negative 1 over root 2, z prime equal to 1 over root 2, and x prime equal to negative root 2 plus minus root 6 over 4. I found that how can we get rid of this case that z prime equal to negative y prime, and we know it is not 0. So let me tell you in which equation, in which of them was related to, yes, here. Y prime z prime, this product equal to this square root, so it is at least 0. So y prime z prime here will be what? Y prime z prime here will be negative y prime squared. It will be less than 0, because we can calculate it is what? It is 1/2 y prime squared. It will be negative 1/2. But we said it should be at least 0, so that's a contradiction. So here we don't need to check these cases, okay? So let me erase case 1 and all these things. Okay. And so we've calculated this. Let's erase this part. So we need to only check case 2. In case 2, we have what? We have y prime equal to x prime plus z prime. Okay, now let's check, for example, first here, 6th equation. If we have this one, now let's replace y prime with x prime plus z prime. So 4x prime squared plus 4z prime. This one we don't have y prime. Let's use something else. In this one we can use in fourth one. So let's erase this part. Okay. Now let's calculate 4x prime squared plus 4y prime squared is x prime plus z prime whole squared minus 4 times x prime plus z prime minus 3 equal to 0. Now we can conclude what? 4x prime squared plus 4x prime squared plus 4z prime squared plus 8x prime z prime minus 4x prime squared minus 4x prime z prime minus 3 equal to 0. 4x prime squared will be cancelled. And here it will be 4x prime squared plus 4z prime squared. 8x prime z prime minus 4x prime z prime will be plus 4x prime z prime minus 3 equal to 0. Okay, we can call it 4, 5, 6, 7 equation. We replace in fourth. Y prime equal to x prime plus z prime. Let's also replace in fifth one. We can say y prime equal to x prime plus z prime. So x prime plus z prime squared plus z prime squared minus 1 equal to 0. So x prime squared plus z prime squared plus z prime squared plus 2z prime squared plus 2x prime z prime plus 2x prime z prime minus 1 equal to 0. Now we have this equation and this equation. So they are similar to each other. I want to subtract. But first, because for example, here we have 2z prime, 4z prime squared. Here we have 4x prime z prime. Here we have 2x prime z prime. So we multiply this one by 2. So it will be 2x prime squared plus 2z prime squared plus, 2x prime squared plus 4z prime squared plus 4x prime z prime minus 2 equal to 0. And if you consider seventh equation here, if they are similar equation, again we subtract. So this minus this part will be cancelled, this part will be cancelled. 4x prime squared minus 2x prime squared is 2x prime squared. Minus 3 minus minus 2 is minus 1 equal to 0. So we conclude that 2x prime squared equal to 1. So x prime squared equal to 1 half. We want to calculate what? X prime squared, y prime squared, z prime squared. So if we can calculate y prime z prime squared is what? The problem will be solved. So here we can use in seventh equation that x prime squared is 1 half. So in seventh equation, because we need x prime, we can consider x prime equal to negative 1 over root 2 or x prime equal to 1 over root 2. So to see z prime will be what? So if x prime is negative 1 over root 2, case, for example, here we had case 2, it is case 2, 1. So 4x prime squared is 4 over 1 over 2, 4 times 1 over 2. This 2, 1 is plus 2, 2. So in 2, 1, 4 times 1 over 2 plus 4z prime squared plus 4 over root 2z prime minus 3 equal to 0. So we can conclude what? We can say 4z prime squared plus 2 root 2z prime plus 2 minus 3 minus 1 equal to 0. So z prime is what? Negative 2 root 2 if you use quadratic formula plus minus square root of 4 times 2, 8 minus 4 times negative 1 will be plus 16 over 2 times 4, 8. So it will be negative root 2 plus minus 24 over 4, 6 over 4. We've divided both numerator and denominator by 2 because we want to divide the square root by 2 inside square root, we should divide by 4. So z prime is this. Now if we want to calculate y prime, we should use this identity. Let me tell you, we've calculated this. We've calculated z prime. We found that what? We found we can say y prime equal to x prime plus z prime. Y prime equal to x prime plus z prime. X prime is what? Plus 1 over root 2. So we should add plus Negative root 2 plus minus root 6 over 4. So there are two cases. So let's consider x, y, z, x prime, y prime, z prime. X prime is 1 over root 2. If z prime is negative 2 root 2 plus root 6 over 4. So let's calculate first this case. Negative root 2 plus root 6. So it will be what? The first one is root 2 over 2 plus negative root 2 plus root 6 over 4. So it will be 4, 2 root 2 minus root 2 is root 2 plus root 6. So it will be root 2 plus root 6 over 4. For this case, 1 over root 2, if z prime is what? Is negative root 2 minus root 6 over 4. Then y prime is what? Root 2 over 2 plus negative root 2 minus root 6 here over 4. So it will be common denominator 4. 2 root 2 minus root 2 minus root 6. Root 2 minus root 6 over 4. Now, product. If we want to calculate x prime, y prime, z prime, it will be what? X prime, y prime, z prime. Here, 1 over root 2, 4, 4, 16. 1 over 16 root 2 times root 6 squared 6 minus root 2 squared 2, 4. So it will be 1 over 4 root 2. And if we say x prime, y prime, z prime squared, it will be what? It will be 1 over 32. Now, if you calculate this case, it will be what? 1 over 16 root 2 times 6 here. If we see this part, it will be negative root 2 minus root 6 squared is 6 minus 2 again. So it will be 4. It will be 1 over 4 root 2. It will be again 1 over 32. We've checked case 1 that x prime is this. Now let's check case 2. 2, that x prime is negative 1 over root 2. In this case, x prime is this. I want to calculate again other parts here. For example, I want to calculate. Let's see for x prime, y prime squared. And we have these cases. So let's see seventh case. Okay, so it will be 4 over 2 plus 4z prime squared plus 4x prime will be negative 2. So let's consider 4 times negative 1 over root 2 times z prime minus 3 equal to 0. So 4 over 2 is 2 plus 4z prime squared minus 2 root 2 z prime minus 3 equal to 0. So 4z prime squared minus 2 root 2 z prime 2 minus 3 negative 1 equal to 0. So z prime is what? Is 2 root 2 plus minus square root of 4 times 2, 8 minus 4 times negative 1 plus 16 over 2 times 4, 8. So it will be 2 root 2 plus minus root 24 over 8. We divide both numerator and denominator by 2. It will plus inside square root, we should divide by 4 over 4. So we know what? We know that here we found y prime, the relationship. Y prime equal to x prime plus z prime. Y prime equal to x prime plus z prime. Again, we consider cases x prime. We know x prime is negative 1 over root 2. Y prime, z prime. So let me write first z prime. Z prime can be root 2 plus root 6 over 4. Or it can be root 2 minus root 6 over 4. And x prime is negative 1 over root 2. Y prime is sum of them. So for first case, it will be negative 1 over root 2 plus root 2 plus root 6 over 4. So this one will be negative root 2 over 2 plus root 2 plus root 6 over 4. And if we use common denominator 4, it will be negative root 2. It will be root 6 minus root 2. So y prime in this case is root 6 minus root 2 over 4. In next case, it will be negative 1 over root 2 plus root 2 minus root 6 over 4. Again, you can use common denominator 4. It will be negative root 2 over 2. And let me write negative root 2 over 2. So 2 root 2, negative 2 root 2 plus root 2 minus root 2 minus root 6. Okay, so let me write this case. Negative root 2 minus root 6 over 4. Now, we want to calculate x prime, y prime, z prime. In this case, it will be negative 1 over root 2 and 16 root 2. This times this will be 6 minus 2. 6 minus 2 is 4, so it will be negative 1 over 4 root 2. So if you calculate x prime, y prime, z prime whole squared, it will be 1 over 32 again. And for this case, again, it will be negative 1 over 16 root 2, and it will be negative root 6 squared, which will be 6 minus 2. Again, it will be negative 1 over 4 root 2, and if it raised to the power of 2, it will be 1 over 32. So in all these four cases, it was 1 over 32. So let's see the problem wants what. The problem says m plus n is what? 1 over 32 is m over n. So m is 1, n is 32. And the problem wants m plus n. So m plus n, which is the answer, is 33. So we've considered all cases of this problem and we've reached rigorous proof because we've considered all cases and we've not ignored any small case. Okay, so you can do this problem as homework. It is easier, but you can use similar approaches. Also, you can use my video that I released this solution. There are around 40-50 important ideas, techniques of problem solving in each topic: combinatorics, number theory, algebra, and geometry. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. Okay, so we finished this idea, two approaches for radicals, these two ideas, and similar equations.